Hello, hello. All right, it's been a while since I streamed on this channel, but this whole DeepSeek thing is going big. So let's play with it and see how this thing works. All right, so I did start just a few minutes ago playing with it, so just to see that it somewhat works. Okay, so what I'm using here to start off with is I started off with this Python OpenAI demos. I'll post this in the chat. This is my standard kind of, starting repo for, especially when I'm teaching how to use large language models. And the cool thing is that you can use it with Azure, you can use it with GitHub models, you can use it with Ollama, or you can use it with OpenAI.com. And and DeepSeek is actually in a lot of those now. So you can do DeepSeek on Azure, though I haven't got a deployment quite working yet. That's what half my tabs are about up there. You can get DeepSeek from GitHub models. And so that's definitely what we're going to start with because that's working well for me right now. You can also get DeepSeek from Ollama. So if we have time, maybe we can play around with that too. But yeah, the easiest right now is GitHub models. So if you go to GitHub marketplace/models, you can select a model here and DeepSeek. There we go, DeepSeek R1, right? And let's see, give me a 1-sentence overview of OAuth2 and OIDC. That's kind of a hard topic. Let's see how it does with that. And you can see it's thinking. It says, okay, I need to give a 1-sentence overview. Let me start by recalling what each of them does. So this is what people like about the DeepSeek model is that it's a reasoning model and it thinks about things and it shows you their thinking process. And that can help you figure out how to, put it on a better path. It's like when you're teaching someone and you ask them to explain their thought process or to show their work, then you can figure out like, oh, okay, that's where you went wrong, right? And then you can guide your student on a better path. The interesting thing is I asked for a single sentence, but in order to come up with a single sentence, it's actually doing a lot of thinking here. I think it's still, okay, there we go. So at the end, it said, let's try this. And then it actually gave the sentence, right? So this is what it actually came out with. So OAuth2 is an authorization framework, blah, blah, blah. Well, I see, but yeah, it's a really good explanation, actually. So now the interesting thing here is that this UI isn't really distinguishing between the thought process and the output. But I think it'd be nice if it did, because on the API level, there is actually a distinction between the thought process and the output. So now let's go ahead and try, try something in the actual code. All right, so let's start with this one here. So this is a basic code. Hilariously, I'm using the OpenAI SDK because the OpenAI SDK works with anything that is OpenAI compatible, and DeepSeek has a API that is roughly OpenAI compatible. So it supports like the basic chat completions. There is some differences, right? So actually temperature, at least the version on GitHub models in Azure just is not supported. So so we can just delete temperature and make a note like not supported. Temperature, I assume top P is also not supported. Function call, like tools, is not supported, right? But we can do a basic chat completion. The other interesting thing is that you can pass in a system message but when I understand it, the system message is not really paid attention to as much, or like not prioritized as much as it is for other ones. So I think the safer thing is actually just to put everything inside the first user message, and then I'll just add a note that system message can be specified, but is not adhered to as much as usual. That's how I currently understand it. So if anyone knows differently, I see John in the chat. Hello, John. And I don't know if John, if you've played around with DeepSeek yet. Okay, so here we have our user message. So you're a helpful assistant that makes lots of cat references, use emojis, write a haiku about a hungry cat who wants tuna. I don't know how much thinking it'll have to do about that, but let's see. And there we go. So we can go and run this. And this is going out to GitHub models. So it's actually this code here it's using. So it says it's using the OpenAI SDK, but setting the base URL to this URL here, which is an azure.com URL because GitHub models is powered by Azure. And then we pass in our GitHub token as the API key. And I'm inside a GitHub code space. So the GitHub token is just already defined. If I was on my local machine, I would create a personal access token on GitHub and export that into my environment so that it existed. And then we have the model name. This is just in my .env, but in this case, we're playing around with DeepSeek, so we can just simplify all this, get rid of this other code so that we can focus on this one. Okay, so that's basically how we connect to it. And yeah, okay, and it's still going. It was faster when I was testing this earlier today. Oh, maybe because now I passed in the system message, it's maybe it's thinking more than before. And so that's one thing about DeepSeek. It's slower. And also I'm starting here with a non-streaming example. And whenever you're doing non-streaming, you have to wait a long time because you have to wait for the entire response to come through. And especially when there's thinking involved, even if it's haiku, it made me think really, really hard about making that haiku. Especially, I wonder if it's actually trying to adhere to the right number of syllables and thinking through that. Okay, so while it's doing that, let's go to streaming because we'll be able to get a faster response. So I'll go ahead and simplify this code again so we can see exactly what the code is that we're doing. Okay, so we're going to do DeepSeek R1. All right, and I'll just delete the system message for this one. Delete temperature. I don't actually know, like, is max token supported? And if so, would that include the thinking or not? Okay, so then I'll go ahead and open a new window while it's thinking in the other one. And hopefully we can get, okay, so now, well, actually the print, okay, there we go. So what you see here is this think token. This is a special token that indicates that it started thinking. And then we see it streaming in the actual, thinking process, right? So it says the user wants a hungry cat. I need to remember the structure of a haiku. It's usually 575 syllables. Let me double check that. Okay, it's double checking. Subject is I need to capture the essence of hunger and the specific desire for tuna. Wow. That's 5 syllables. And I feel bad about how much it's thinking about this haiku. It's like a lot of effort. And it's thinking back, it's trying to count the syllables. Like, does it get it right? Whispers, hunger in bright eyes. I think you got it right. And then tuna, dreams, rise warm, 5 syllables. Let me check the syllables again. Line 3. Yes, that fits. The imagery flows. Dreams adds a layer of aspiration. Is there a better way to incorporate tuna? I think it works. Okay. Wow. So this is why I wonder if it finally finished in the other one. It did. Okay. So now we can look back in the other one and see that it went through a really, really long process. So what I thought was a fairly simple request involved a ton of thinking. And then this one finally said, velvet paws, drum loud, tuna scent, hijack, moonlit dreams, yowl, where's my fish? And then it said, keep the tuna coming, human. But that's not part of, that shouldn't be part of the haiku, right? Where did that come from? Okay. Interesting. So throw in one last line. All right, then let's check back at this one. And this one feels like it ended. Oh, because this one has the max tokens. Okay, so it looks like max tokens is supported. Max tokens is supported, but it may, you know, that may end up cutting off a thought process, right? So you have to be really careful with max tokens. So that's what happened there, is that it just stopped. Okay, and then we could try the one before. Please explain OAuth 2 and OIDC. All right, so you do want to be careful. You want to be careful with max tokens, temperature. So that's okay. Not supported. We assume these ones are all not supported. Oh, we could also check the GitHub Models Playground to see what they put in the parameters. So, oh, they did put max tokens in there, and they did a really, really big one, which makes sense. And oh, they also did stop. Oh, I heard that maybe. I wonder what we should put for that one. That's interesting. Okay, stop. Is that also part of the OpenAI SDK? Stop. Stop. Does it know about stop? Stop. Yeah, it knows about stop. Okay. Okay. Stop is also supported. I haven't used stop with the OpenAI SDK. So to think about when we would use that. All right, and it's thinking through this one again. Okay. So what's interesting about this is the thinking, right? And if we're going to use this like in a UI, then we want to know the difference between the think blocks and the non-thinking part, right? So how would we do that? So the cool thing is the think is always its own token from what I've seen, and that would make sense to me, right? Is that when you're streaming, if you're going to get the think, it's going to be a single delta in the stream, and it's not going to get cut up over multiple lines, right? So what we should be able to do is, you know, like let's say like is thinking equals true, or we'll start it as false, and then say like if content equals think, then is thinking equals true. We could print thinking and not actually print the think, which is nice. And then as it comes in, okay, and then at some point we'll get the end thing, which it made up there. LF content equals think is think equals false, and we'll just, how do we want to distinguish? Like the front end, we can make it a lot prettier. Let's do like an emoji. What's a good emoji for stopping? We'll just say stop. Okay. And then as long as there's otherwise, as long as the content is non-empty, we will show it. All right. So I want to give it something that's easier. Who painted the Mona Lisa? Yeah, the stop sign. That's what I ended up with. Maybe we should do another emoji here. Let's do brain. This one. And then brain stops. Okay. All right. So hopefully who painted the Mona Lisa, because it is still thinking about OAuth 2 and OIDC. Gosh. It's super interesting. This is the first time I'm playing with it. So this is actually really, really interesting for me to see. Okay. So it should start thinking. Okay, great. So it said thinking. We got that brain. I remember it's displayed in the Louvre, but who actually painted it? It's one of those classics. The name Leonardo da Vinci. He was Italian polymath. Yes, I read his biography recently. Actually, he's really, really interesting biography. He loved to start things, and he didn't finish a lot of things. And the interesting thing is, like, he started all these books, and he never finished them and published them. And I think most of them got destroyed. But like, if he was somebody who liked finishing things, then we would just have so many things by Leonardo. And yeah, there you go. Yeah, he actually it knows quite a bit. It's interesting how much it's thinking about this question. Like it's kind of like gut checking itself quite a bit. Oh, but I guess there's been controversies. Okay. There were controversies over some of his other stuff, but the Mona Lisa was pretty straightforward. Wow. This is so fascinating. Okay. All right. So it stopped thinking. All right. So that was the end of the thinking. So that was our thinking. And then here's the actual answer. And it looks like they use asterisks for highlighting stuff. So if we were doing something in the front end, we might want to, maybe this is basically markdown. Yeah, it's basically markdown. So probably want to, so I guess this model does default to outputting markdown. So maybe that's what it was trained on. So that would be good to render markdown as HTML. There's a lot of packages you can use for doing that. Okay, so great. So then we got the thinking. All right, well, so now I want to actually kind of want to build a front end for it now. Or play with Ollama. What should we do next? Let's see. We do also have a little article here about the whole thinking thing. Like, because the other approach is that if you're doing the non-streaming, you can, regex out the thinking process. But gosh, now that I see how much it thinks, like, I think it's pretty important to be using streaming if we're using it in a user-facing thing, right? Oh, thank you. Aditya likes my light theme. Yeah, I can only do light themes. I actually have a really hard time with dark themes. I think it's especially because I got LASIK like 15 years ago. So I generally have a hard time with the dark themes. Or maybe just because I'm getting older. Who knows? All right. So we can either do, well, let's go ahead and try an Ollama. Let's see if I have enough space on my machine to get another model, or we can, kick another model off. So let's see, what is my storage like? I'm always perennially almost out of storage on this machine. Okay, that's pretty good. I got 40 gigs. I think we can make that work. So right now, is there anything I want to delete? I have 3.1 latest and 3.1 8B. They're both the same. I think I'm just gonna remove the 8B one because it looks basically like the same as the latest. And then we're going to go to Ollama and look for DeepSeek. There we go. Oh, there's also another DeepSeek, the coder one. There's actually a bunch of DeepSeeks. Okay. But this is the reasoning one. All right. So now there's a couple ones here. I think I could maybe even go for the 14B. I don't know. I also don't have a huge amount I've got 16 gigs of RAM, right? So I think the safe thing would be the 8B, since I've done that with Llama. And we can see how the 8B performs. All right, so it's downloading. So while it's downloading, I'll open some code. I'm also, for those of you curious about deploying it with Bicep, you can see I was working on that today. Unfortunately, this is not quite working. Once it's working, I'll stick it in a branch. There is a server error that the team is looking into with this Bicep, with DeepSeek specifically. So not working yet, but pretty soon we'll have Bicep to deploy it. And the Bicep will be even easier like a week from now. We're just a bunch of Azure changes happening. Okay, so let's go ahead and open the Ollama, my Ollama Python playground. All right, so this one is basically like the one we were looking at, but it's dedicated for only Ollama when I know I'm just using Ollama. So this connects to the Ollama local host here. So you can see the base URL is localhost 11434/v1. You need that /v1 because Ollama exposes two servers. One of them is its own server protocol, and the other one is the OpenAI compatible server, and that's /v1. So you need /v1 if you're pointing the OpenAI SDK at it. Now, of course, we're going to change the model name let's say hi. I don't think it's gonna say much back because it doesn't understand hi, but we'll see how we'll see if I can even. Oh, there we go. Think. Look at that. It thought nothing. That's also, if someone says hi to me, I just think nothing. That's great. So it's cool. So it doesn't always have a thinking process. Sometimes thinking is blank. That is another thing that we've learned. Let's keep that in mind. I'm trying to remember all these learnings. Okay. So no key needed. Okay, remember, let's just copy and paste from our GitHub models playground. So we have everything in here. Okay. Okay. Here we go. Oh, let me activate. Oh, I'm in my Python environment. Great. Okay. All right. And all right. Now we figured out the fastest thing we can ask is hi. So let's try that. And if any of you have ideas for something you want to ask R1, you should put it in the chat. So that, especially if you can think of something which isn't going to take a million years. All right. So here we can see thinking, and it thought nothing at all. So that's interesting because I don't know, like maybe in a user interface, like with an HTML user interface, it would probably just go away very quickly. But what you could do is only display that thinking if you see a non-empty chunk after that, right? Actually, it looks like it did get a chunk. It looks like it got maybe I wonder, okay, now I want to see exactly what's in there. Elif is thinking. I'm gonna like print out. I just want to see what's in there. Okay. Thought. Okay. All right. Let's try that again. Oh. Positional argument. What did I mess up? Oh, flush. What was the flush? Oh, flush equals true. Sorry. Okay. Okay. So we have, so Aditya. Yeah. So it did have a thought, which was a new line. I really have no interest in outputting new lines. So I want to think about that. Okay. So Aditya says, thinking of building something with DeepSeek, a mini project. Do you have a recommendation? Yeah, it's a good question because I'm really new to reasoning models and like what they would work well for. Like, I feel like they work well for like making like thinking through something, like making arguments for and against something, but I don't know why you'd need that. So I feel like yeah, I don't know. Something, uploading I don't know how well, so I have to see how well it works for like a large context. Maybe we can try this here. Is like, let's like download a file and then like ask it to do, and some sort of explanation of it. Now we already can do summarization pretty easy, right? So something more advanced than summarization, like saying like, okay, in this like city council meeting, they argued about, such and such topic. What is the argument for and against it? Like maybe that would be a good use for it. I guess people use reasoning models all the time for like logical problems, but I don't have like logical problems that I need to work through most days. Or there's also my colleague Anthony. He did a stream yesterday with trying to use DeepSeek for reasoning about coding improvements, and I think he got some interesting results from that. So that's, we're all coders here, right? So you could be passing parts of your code base to it and saying like, hey, can you analyze this for performance issues, safety issues? And there, the thought process could be really interesting. So yeah, I don't know. That's some thoughts. Where I think we're all trying to figure out like what are the big use cases and scenarios where we really want those reasoning models, and like what are the generic ones that are useful for all of us. All right, so as we can see, it says thinking, and it did have a thought, which was a new line. And And yeah, and that would be like, in this case, not that useful, but it's fine. We can just let it do that. All right. So I'll say, I'm just gonna make a note. This is sometimes followed only by a new line, because maybe in a UI, I wouldn't want to show it at all if the entire response was only a new line, but I'd have to be like watching that. So I think in a UI, I would only want to show the thinking when I got the first non-empty piece of content. And then I would kind of like clear the buffer and show everything. That's just a thought. All right. So we got back an answer. So let's try giving it more context, right? I do have I have a CSV here that we could read in, or we could read in like a PDF, maybe a PDF, and try sending it. Like, well, I guess first we'll start with the CSV just because I have it. So let's just open hybrid.csv and send to model with no, they're not gonna be like rows. Okay, so we bring in the rows. All right, and then we're gonna say this is about hybrid cars. So say what is the fastest, let's say what is the fastest hybrid car? Here is a CSV with data. And then we'll go and pass in the rows. We could just do, I was just thinking of joining the rows. Yeah, that's what I was thinking. Okay. All right. And that ended, join rows. The hard thing about putting, oh yeah, you can't do it. Okay, I'm in an older Python. All right. CSV data. There we go. All right, we'll just do that. And no, I want to join it with a new line. I could have just read the whole file out, right? Silly. Okay. There we go. All right. Let's try this out. It seems like it's being slower, and that's probably because we sent it a lot more data. We also might want to switch back to GitHub models if this is too slow. That's okay. All right, so it says I need to figure out how many cars. You don't really figure out how many cars. You need to figure out, okay, figuring out the format, taking the first line. Well, the first line was actually the columns, but it's saying it's year, make and model. Oh, I guess that's like make and model. Year, MSRP, type. I don't even see type. Oh, type is class. That's class. Okay. Fuel efficiency. Did they make it up to 2018 Toyota Camry? I don't even see that. Did it make this up? F type sport? Wait, where did this come from? What? Tesla? Is this completely... What just happened? CSV data. Here's a CSV with data. Yeah, but MPEG is fuel efficiency. Okay, but it's still weird. Like I don't think there's Tesla in here. Oh, maybe Model S. No. Okay. It just says like Civic. There's no Tesla. Chevrolet Volt. I don't think any of these were from the data. No Impreza. Where did this data come from? Okay. I'm just gonna search in the folder. Just no. This is crazy. Okay. All right. Well, we got our hallucination here because this is like there's none of these were in there. So did I mess up what I sent to the model somehow. Let me just put the message in a string here so we can see it. And then print the message. Oh, actually, I'll show you a different trick. Here's a different trick. Okay. When you're using the OpenAI SDK, what you're going to do is import logging. And then we're going to set up logging to debug level. All right. So we just say logging basically level equals logging.debug. Then we should see the network requests that go out from the OpenAI SDK. So that's what I do sometimes when I'm trying to verify what actually happened. So let's see what gets sent out. Okay. So now we can see this is what got sent out. So you can see what is the fastest car. Here's a CSV with data, vehicle year, blah, blah, blah. It's got Prius, right? The first line says Prius. And there's no Tesla in it. And it says, okay, the users write a long list. The sales column, there's no sales column. What? Okay. It's just completely making it up because it says that it's giving a price. There's no price in this. Oh my gosh. All right. So to be fair, we're using the 8B model. So let's go ahead. Let's try this with the GitHub model because, MSRP is sales. Okay. Also, I don't know anything about cars, so this is hard for me. MSRP. Oh, sorry. Okay. So finally, okay. You're right. So that is, okay. Escalade. All right. Maybe it did do better. Okay. The sales column. It's weird that it's calling it the sales column though. You would think it would call MSRP. Features comparison. Honda. Okay. And notice each entry has a model name, starting year. That's correct. Sales figures. Okay. Engine details. Well, there's acceleration. Features. There's no features, right? And some prices. Sales figures sounds like how much you sold in a year, not how much it costs. And it says this data spans multiple years from 2011 to 2016, but this starts at 1997. So it still thinks, I still feel like it's completely and utterly hallucinating. So this model, 8B, very hallucinatory if we're trying to do something kind of, raggy, like grounding it in something. But let's go ahead and try this out with this one instead. So I'll go ahead and make a new file. So we're kind of doing like our kind of rag DeepSeek. Okay. And let me bring in all the code here, and then we'll just change it to point at GitHub models. Okay. And it's okay. All right. Oh, I've got my rough in here. Okay, here we go. All right. So this should be, does it say on GitHub models? Parameter, how big this model is? Compare. Oh, that's if you want to change it. I think you can see like the model parameters when you go to, where do we get to see the model ones? Like learn more. Code, raw parameters, 128K. All right, well, I'm going to assume it's the full model because typically that would we would do if we're not providing other ones. All right, and so now let's try rag with DeepSeek. Let's do it. Kind of rag. All right, are you going to make up stuff? First, I should figure out what metric determines fastest. Okay. Acceleration time. All right, so this looks good. Lower number means faster acceleration. Let me check the CSV headers. There's a column for acceleration. Okay. So this is doing much, much better. Let me scan through the list. The Prius has 7.6, which seems pretty quick. Then Tino has 8.2, which is slower. I wonder what it's doing when it's like scanning through the list. Is it really scanning through the list? I don't know. The insight. Okay, so now we can like really double check this. So that's the cool thing about using this for RAG actually, is that you can actually double check it along the way to verify, like, okay, like at no point did it make something up, right? This is actually super helpful because I wouldn't be able to answer this question myself because I know so little about cars and I wouldn't even know like how to go about it, right? So like the fact that they're saying acceleration lower is better. I guess, and I know there's that phrase like 0 to 60 in blah 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 seconds. So I guess that's what this is, the blah blah blah. But it helps to have something that knows more than I do. All right, so let's see. So moving to 2006. Okay. So it's going through the list one by one. So it's really interesting because I feel like it's doing a really good job on this, whereas the 8B model just really didn't at all. So maybe the 8B model, you can use that for creativity stuff. Like when we were using it for making the haiku, it was okay with that, although it did add in, well, actually even the big one added in an extra line sometimes. Okay, so we definitely should be careful about using the 8B. Well, at least for the things we've tried here. All right, it's still going down. So it's basically like the thinking time is, okay, we're down to Durango. So the thinking time is going to depend on how much data we send to it. So if we sent it a really, really large list, then probably the thinking is going to scale in regards to the list. If it feels like it has to look through the whole list, like this is almost like algorithmic complexity, right? Like with algorithmic complexity, we talk about like O of 1, O of n squared, right? So this so far is at least like an O of n, where it's going through every single item in the list. So that means like if we sent it a longer list, we would expect the number of tokens to roughly scale with the size of the list. All right, so as it's going, so we had a question from Mahesh. How should I start learning AI models? What's the best way? Well, yeah, it depends like what you want to do. If you're going to do it in Python, I do have like it's like intro to large language models. This is usually a stream that I do. Let's see, using large language models with Python is on here. Oh, and it's just even, I just streamed it to my channel. So you could check out this this video I did earlier. It's based off of a lecture that I give at UC Berkeley most semesters. And I think I'm thinking of doing a Python Gen AI reactor series in March to do this one, also talk about, we've talked about vision models. I've talked about vector embeddings, and talked about structured output, right? So there's different aspects. Oh, here's another one. I forgot. We also did this one. Okay, this might be a little more up to date. This should be pretty similar though. Yeah, generally you can find other ones I've done. So those are designed to be intros, especially if you're going to be using Python. And then you can, there's books you can read too. Like I'm reading right now, Chip Huyn, AI engineering book, and it's really good for a overview of, well, so far what I'm reading is like the overview of the whole like AI engineering ecosystem, but then it has tons of stuff. So like all the use cases, she has an ML background, so she actually goes into how foundation models work, which you don't actually have to you don't really have to understand this in order to start working with language models. So this might be, a little later. There's also, I have a colleague that wrote a different book that might be more kind of beginner friendly. So generative AI in action, from Amit. And so this we could do if you like books, right? I haven't read through this yet, but it does look, it looks like pretty well geared for getting started with. And then there's also, wait, let me link this one. And then there's also, we have this generative AI for beginners course. This has a mix of Python and other languages. And this is very popular with people learning too. So lots of way to learn. Just start somewhere. As usual with learning, like start somewhere. do things that are hands-on, right? Like actually run code and see what happens. Like, I mean, I'm learning so much today from running all this code, right? And yeah, and when you get intimidated, you know, it's fine, just take a break, because it's always tricky to learn things, but it's really fun too. Okay, so it went through the whole list, and it said, so finally it was like, it said, it said this one with 6.29 acceleration. The user asked for the fastest hybrid. Lower is better, so that the Fremont, let me confirm the any typos. Okay, that's very fast. Okay. All right, so it basically went through the whole list and said, blah, 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 is the freed spike. Okay, let's make sure that's in here. I never even heard of that. Okay, the freed spike, 6.29. And it provides all the information, and it even provides ones that are close. That was really cool. I wonder how GPT-4o would, like, because now we can, so the nice thing about using GitHub models is that we could now compare it to like a, you know, GPT-4o. I think we even have O1 on here too, so that actually would be a good one to compare it to. So if we did that with like GPT-4o, which is what I usually use in situations like that, well, first, hopefully it's gonna be a lot faster. So we definitely have to think for DeepSeek, like, where's the situation? Like, look how much that was so fast, right? So when we're using DeepSeek, we have to be ready for it to be slower, at least now. Like maybe we'll find ways to speed up the inference as time goes on. But currently, you know, there's a definite latency to it. But for some answers, it might be worth it, right? Now, in this case, for this question, I should just load it into a spreadsheet and then sort it. But I was asking a question that I didn't necessarily even know how to answer, right? All right, so it says we need to look at the acceleration value. Lower acceleration times means faster car. Here's the analysis. So they found the freed spike. So that also got the right answer. It didn't provide the closest ones, but we also didn't specifically ask for the closest ones. Now, do we have a marketplace model for O1? Let's see, select a model. O1? Yeah, we do have O1. All right, let's compare to O1. See how that one goes. Oh, you got an error? What's the error? What did I mess up? Unsupported value stream. Oh, you can't stream O1. Well, noted. I guess that's another, I didn't realize you can stream O1. That would be another reason to use DeepSeek R1, is that you can stream back that response. That's really interesting. Okay. I mean, we can try it without streaming. You just say boot, and then we're just gonna get back the response. Here we go. Rag DeepSeek. Okay. All right, and I'll just exit, and I'll just be completion. All right, let's try that. Are there any other ideas about what we should try here? We've done GitHub models. We've done a llama. We've done streaming. We've done a bit of RAG. I guess we could try a logic problem. We could try, so there's no function calling or structured output. So that's not a good use case right now for DeepSeek. I could try RAG, like basically, okay, what I could do is get back the system message. Okay, so this one, like so this is RAG with AI search, right? And we could just straight up send, because I have the full messages here. So we could send this to Deep Dive and see what kind of response it would get. DeepSeek. Okay, it's still, O1 is still thinking. I'm just gonna prep the other one while it's thinking. All right, CP RAG DeepSeek. We do RAG with AI search. Kind of, it's not really AI search, but it's the same content. Okay. And instead of this, I'm just gonna paste in. So these are the messages, but as we were saying, DeepSeek R1 doesn't necessarily pay as much attention to the system message. So I'm going to go ahead and take that and just put it at the top, at the front of the user message. And I'll just put a bunch of new lines. Okay. All right. So this is really, that's it. We're just going to go down here. And if we're going to do this DeepSeek, we can bring back our streaming, and oh, it should be messages equal. And it's a list. Good, stream true. All right. And we're going to change this back to our DeepSeek R1. Okay. All right. So now we're sending it RAG on document chunks and seeing how it does with that. All right. And let's see. Did O1 ever succeed? Okay. So this was O1 with the acceleration thing. From the acceleration column, lower equals quicker. The quickest entry is the Honda freed spike. Oh, it's interesting. I knew it was from Honda. Did it say that in the thing that it was Honda? I guess it would have, right? Freed. It doesn't say Honda. So it knew it was Honda because that's in its weights. So that's the other thing, is like how much stuff is in the weights about like just popular culture. I don't see anything here saying it was Honda, but it did know it was Honda. So they all got the right answer. Yeah. DeepSeek R1 showed us the thought process and streamed it, and took longer because it was doing all that thinking. All right, so now let's try doing this sort of RAG. Oh, and let me. There we go. All right. Okay, so it's going to start thinking about this. So it needs to look through the different sources. So looking at benefit options, page 3. So it's able to distinguish between our sources. And sees what it does. Then it looks at the next source. And it sees what's in standard. Okay, so it was able to look at the sources. So once again, O of n, right, that the thinking time is going to scale based off the number of sources that we send it. And let's see how it does with citations, because I asked it to put citations in a particular format, and a lot of models struggle with this. In this case, it did a really good job. It did it. Great. This is awesome. So Northwind Plus has several features: coverage for emergency services, which standard does not, and it references the page. Hospital stays and x-rays are covered in Health Plus, while standard only covers doctor visits and lab tests, page 3, and broader prescription covered. So, and it said the sources don't mention additional exclusive benefits. That was really good. That was pretty good. And I like the citations. So I think this could be a reasonable thing to use as long as we're using the biggest model. Okay. All right. I think I have to head out for today. But this was super interesting. I can either, if people want the code, I can put them in a branch, or I don't know if we should have like a separate DeepSeek repo or something like that, just for DeepSeek experiments, see what works well. But I learned a lot actually, and it was very fun to explore DeepSeek today. And hopefully we'll have some DeepSeek templates and notebooks and all that for you soon. Okay, bye everyone.